Okay, so Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Hi. Mana semua orang ni? Hi. Alright, so don't forget to key in your attendance. Hi. Lupa pula. Assalamualaikum. Tadi duduk hi. Cuba bagi salam sikit. Hi again. Okay, so today we are going to start with a new chapter, chapter 10, application of differentiation. So well done, everyone. Well done. Finally, we are at the last chapter for SM015, which is chapter 10. Hooray, hooray, yay. So we're going to finish chapter 10 and then I'm thinking of doing an extra class this weekend, but I'm not sure yet. Tapi rasanya okey je kot kalau habis hari Ahad pun. Tiba-tiba je rasa macam okey je. Okay, so now we're going to start with application of differentiation. So 10.1, so we are going to look at the extremum problem. Okay, so now let us go to the next slide. Okay, at the end of the lesson, firstly, you should be able to find the critical point. So we're going to learn how to calculate the critical point. The second one is that you need to learn how to find the relative extremum using the first derivative test. So we actually have two tests in extremum problem. So we either have the first derivative test and another one is the second derivative test. So first derivative test, second derivative test. The last one, we're gonna try to solve for optimum problem. So we're gonna solve optimization problem. So optimization problem, we will need to use the first derivative as well as the second derivative test. So sebab tu dia datang serentak dengan kuliah first derivative dengan second derivative. Okay, so let us go to the first one, find the critical point. Right, so extremum problem. So a critical point for a function fx is any value of x in the domain of f at which f prime of x equal to 0 or when f prime of x is not defined. Okay, so we have critical point. Critical point we can get from two ways. So the first one, if let's say you have f prime of x equal to 0, and if you do have some fraction, then it will be the point when f prime of x is not defined. So this one is normally if we have a fraction. Ini biasanya kita ada fraction. If let's say our fraction we have 0 in our denominator, then that means f prime of x is not defined. Okay, so the second one, the critical point where f prime of x equal to 0. So critical point separate into two, f prime of x equal to 0, f prime of x is not defined. So this one are called the stationary point. So these are actually the stationary point. So there are two different things that you need to know. The first one is critical point, and then another one is a stationary point. So those are two different things. Okay, so next, the first derivative test. Okay, so basically suppose that C is a critical number of a point F that is continuous on an interval A until B. So critical number again, either F prime of X equal to 0 or F prime is undefined. Okay, so if let's say we have F prime of X greater than 0 for A until C, so we have an interval A until C and this is greater than 0, so increasing. F prime of X is less than 0 for C until B, then F has a local maximum at C. So yang ini kan kalau kita sambung, we're going to get the highest point. So that is how we know this is a local maximum. Okay, the second one, if f prime of x is less than 0 for a until c, less than 0, that means it should be decreasing, so going down. And f prime of x is greater than 0 for c until b, so going up. Then f has a local minimum at c, so you can actually combine these 2 points together. So we're going to see we have something like a smile graph, therefore we're going to have a minimum point. Okay, so now if f prime of x does not change the sign at c, then f simply has no local extremum at c. So we're going to see the graph later on. Okay, so it is easy to remember the first derivative test by visualizing the diagram. So for example, this one, the local maximum. How do we know we have a local maximum? So it will be something like this, local maximum increasing here, decreasing there. Therefore, we can meet at the highest point over there. So that is a local maximum. Another one, local minimum, going down, going up. So if you simply sketch a graph, you're gonna get something like a smile graph. So this is a local minimum. What does it mean by it doesn't change the sign at C? So for example, something like this. Okay, so this is point C. So this is increasing. This is also increasing. So we don't change the sign. So increasing, increasing. So dia tak ada tak ada local minimum, apa? Minimum point or maximum. Okay, another one. Going down. Again, not a maximum, not a minimum then. Okay. Example 1. Find the stationary values and stationary point of the curve fx equal to 3x to the power of 4 minus 4x cubed minus with 12x squared plus with 5, and determine the nature of that point by using the first derivative test. Okay, so we need to find the stationary point. So stationary point, therefore you need to know what is your f prime of x equal to 0. So let f prime of x equal to 0, and then we're going to find out what is the value of x, and then we're going to substitute to find out the value of y in order to get the stationary point. Okay, so start with fx first. So fx is 3x to the power of 4 minus 4x cubed minus 12x squared plus with 5. And then you're going to differentiate them once to get f prime of x. So you differentiate using the power rule. So it will become 12x cubed minus 12x squared minus 24x. And then we're gonna let them equal to 0 because we want to know what is the stationary point. So factorize first. So we got 12x, x squared minus x minus 2. And then factorizing this quadratic, you're gonna get x minus 2, x plus 1. And then of course, you're gonna let them equal to 0 now. So when f prime of x equal to 0, you're gonna get, let's see how many values. So 1 point here, 1 point here, 1 point there. Okay, so x equal to 0, x equal to 2, and x equal to negative 1. And then we want to find out what is the point. So when x equal to 0, so simply go back to fx and substitute x equal to 0. So 0, 0, 0. So we are going to get 5. So the point for this one is 0, 5. Okay, the second one, you're going to substitute with x equal to 2. So substitute inside fx again, substitute x with 2. So 3, 2 to the power of 4 minus 4, 2 cubed minus 12, 2 square plus with 5. And then we do have 0, negative 27. So that means the point is 2, negative 27. Another one, x equal to negative 1. So we got 3, negative 1 to the power of 4, negative 4, negative 1 cube, minus 12, negative 1 square, plus with 5 equal to 0. So this one, the answer is directly equal to 0. So the point is negative 1, 0. Okay, so the stationary values. So if we are talking about stationary values, that means we are looking at the value of y. What is the value of the y? So the value is 5, -27, as well as 0. So those are the stationary values. If we are talking about stationary point, then the stationary point are 0, 5, to -27 and -1, 0. So those are two different things. Stationary values, it will be referring to the value of the y. Stationary point, therefore we need to write them down in the coordinate form. What is the x and what is the y? Oh, by the way, yes, Dira, why did you call for me? Nak cakap hi ke? Hi. Okay, next. Okay, so stationary point are 0, 5 to -27 and -1, 0. And then it said in the question that we have to determine the nature of that point. What does it mean by nature of that point? That means we need to know, is it a maximum point or is it a minimum point? Okay, so we have these 3 point over here. So now we need to know, do we have a maximum point or do we have a minimum point? Okay, so firstly, what do you need to do for a first derivative test? We need to draw a table first. Okay, so draw the table. The first one belong to the interval. So this one correspond to the value of x. And then based on that interval, we're going to see what value of x that we want to substitute. And then substitute the value of this x into f prime of x. So we want to see, do we have something that is positive or do we have something that is negative? And then basically the conclusion, do we have something that is less than, going down, going up, and so on. Okay, so for example, so we have 0, 2, -1 here. So if we draw our number line, so we're going to have -1 on the left hand side, 0 right in the middle, and then 2 on the right hand side. So I will have 4 different intervals. So this is my first interval, starting from -infinity up until -1. The second interval will be starting from -1 up until 0. The third interval will be starting from 0 up until 2. And the fourth interval will be starting from 2 up until positive infinity. So let us write down the interval first. So negative infinity, -1, -1, 0, 0, 2, 2 infinity. So now let us think a little bit. What is the number inside each of this interval? Okay, so for example, negative infinity until -1. What are the numbers that you know between negative infinity until -1? Any number will do, but it should be inside those interval, of course. Tapi tak boleh ambil hujung-hujung ah, hujung-hujung tak boleh. So that means you cannot choose -1, but you can choose something that is to the left of -1. So in this case, I'm choosing -2. Between -1 and 0, so I choose something in between -1 and 0, and that is -0.5. Something that is between 0 and 2, so you can choose any number. So you can choose 1. 2 until infinity, again, that is quite a lot of numbers, so you can choose any number that you like. But for me, I do prefer to keep it simple, so I'll choose 3. Of course, if you don't want to use 3, you can use 7, 5, 10, apa lagi, 100, whatever. Guna je berapa nombor pun. But normally, keep it simple, better. Okay, so now, sign of f prime of x. That means you go back to your f prime, and now substitute the value here inside this. So for example, this one, we're going to get 12 times with -2, and then -2 minus with 2, and then -2 plus with 1. So you should calculate that one first, and then check, will it give you something that is positive or negative? So itu je yang kita tahu, positive, negative. Okay, so try to substitute x with -2 first inside your f prime. So ganti. And let's see, what do we have? Okay, so I'll give you a few minutes for you to fill in this blank. Positive, negative, positive, negative. So I think 1 minute will do. Nak masuk nilai je kan. So 1 minute for you to try to fill in positive or negative. Hanya semua. Okay, so done with 1 minute. So now let us see what is your answer. Okay, so now if I substitute, I'm going to get negative for the first one and then positive, negative, positive. Okay, so if we do have a negative as the sign for f prime, then we're gonna draw and apa awak panggil anak panah turun bawah. Senang. Then positive, going up, going down, going up. Okay, so draw them. Okay, so going down for negative, going up for positive, going down for negative, going up for positive. So that simply means that the maximum point is 0, 5 and the minimum point are negative 1, 0 and 2, negative 27. So over here at x equal to negative 1, we can see here this is going down, going up. So this is a minimum point at x equal to negative 1. So this is minimum. Over here is x equal to 0. So going up, down. So these are the maximum. And then over here, going down, up. So this is x equal to 2. So this is a minimum point. So that is why it said over here, the maximum point is 0, 5. The minimum point are negative 1, 0 and 2, negative 27. Okay, so done with the first example. Let us go to the next one. Okay, example 2. Find the critical numbers and determine the relative extremum of fx equal to 9 over 5, x to the power of 5 over 3, minus 18, x to the power of 2 over 3. So let us differentiate this first to get f prime of x. Okay, so fx is 9 over 5, x to the power of 5 over 3, minus 18, x to the power of 2 over 3. Do make sure to use the power rule for them. So f prime of x is 3x to the power of 2 over 3 minus with 12 x to the power of negative 1 over 3. Okay, so simplify them a little bit. So if you do have something that is within the same base, so this is the same base because we have x to the power of something and x to the power of something. So if we have a similar base, the thing is you should factorize the lower base. So the lowest between those two, the lowest one, the lowest power, the lowest base lah, the lowest power. So this is 2 over 3, this is negative 1 over 3. So that means negative 1 over 3 will go out. And then you should think a little bit. This one is definitely x to the power of something. So x to the power of what? So that if you plus with negative 1 over 3, you are going to get 2 over 3 back. So that is how I know this is definitely x to the power of 1. So that if we have x to the power of negative 1 over 3, I times them with x to the power of 1, I will end up with x to the power of 2 over 3. So yang ni fikir sikit lah. Okay, so we got a negative power, bring them down. So we have 3x minus 4 over x to the power of 1 over 3. Okay, so now When f prime of x is equal to 0, it simply means that 3x minus 4 over x to the power of 1 over 3 is equal to 0, and I can solve them to get x equal to 4. Okay, another one. Since they asked for the critical point, so for critical point, we have two ways to calculate them. The first one is when f prime of x equal to 0. Another one is when f prime of x is undefined. So f prime of x is undefined whenever we have 0 in our denominator. So that is why it said over here, f prime of x does not exist or f prime of x is undefined when x is equal to 0. So once our denominator equal to 0, we're going to get something that is undefined. Okay, so the critical numbers are 4 and 0. So those are the critical numbers, not the critical values. Critical value correspond to y. Critical numbers are the x value. Okay, so these are basically the first derivative test. So the critical number are 4 and 0. So draw one number line first. We need to know how many interval do we need to draw. So 0 will be here, 4 will be here. So I'm separating them into 3 interval. So first interval, second interval, third interval. Okay, so the first interval will be starting from negative infinity up until 0. The second interval will be 0 up until 4. The third interval will be 4 up until infinity. So let me draw that. Okay, so now the value of x. So let us think a little bit. What number do we want to substitute? From negative infinity until 0. So think a little bit. And then 0 until 4, what number should we substitute? 4 until infinity, what number should we substitute? So basically, you can choose on your own what number do you want to use. Okay, so I choose negative 1, 1, as well as 5. Okay, so now f prime of x. So earlier, we already have our f prime of x. Just in case you couldn't remember, then let us go back to f prime. Kalau tak ingat kan, so kita patah balik. F prime is this one. 3x minus 4 cube root of x. So f prime of x, this is 3 x minus 4 over cube root of x. Okay, so now substitute x with negative 1 inside here as well as inside here. What are you going to get is something that is positive. If you do substitute with x equal to 1, you are going to end up with something that is negative. If you do substitute with x equal to 5, you are going to end up with something that is positive. Fathah jangan ambil nombor hujung Fathah. Negative 1, 1, 5. Okay, good. Okay, so now the conclusion. So we're going to draw. Is it going up or going down? So sekejap. Let me pronounce them correctly. Sometimes I do pronounce them wrongly. Arrow, error, arrow, arrow. Error is an error, right? Arrow. So we're going to draw an arrow going up or going down. Okay, so positive going up, negative going down, positive going up. So now let us see, is it positive? Is it a maximum or minimum? Okay, so going up and going down, so this one is a maximum. Going down and going up, therefore this is definitely a minimum. Okay, so I will have a maximum at x equal to 0 and a minimum at x equal to 4. So since I need the point, I will find out what is the value of y. So when x equal to 0, f0 is equal to 0. And when x is equal to 4, the value of the y is negative 27.2. Me substitute at f prime. Yes, I do substitute at f prime because I need to know what is the value for the gradient. Sebab yang penting dia adalah value dekat gradient. Untuk yang ini lah. Untuk tahu maksimum atau minimum, kita akan ganti dekat gradient. But for this one, I want to know what is the value of y because I need to get the point. So kita nak dapat point dia kan. I already know I will have a maximum at 0 and a minimum at 4. So now I need to know what is the y value. So for this case, I'm substituting at fx. So I substitute with x equal to 0, I get a 0. When I substitute with x equal to 4, I get negative 27.2. Therefore, 0, 0 is a maximum point, and 4, negative 27.2 is a minimum point. So one is maximum, another one is a minimum. Okay, so done with the first derivative test. So we need to go to the second test called the second derivative test. Okay, so basically for the second derivative test, we're gonna do the first derivative test, the first derivative first. So calculate the first derivative and calculate the second derivative. Once you have the first derivative, then you're gonna let them equal to 0, and then you're gonna substitute inside the second derivative. So if let's say your second derivative is greater than 0, then fx has a local minimum. If you have f prime of x equal to 0, f double prime of x is less than 0, then this is a minimum. So f double prime less than 0, so this is maximum. F double prime greater than 0, this is minimum. And if let's say your f prime of x is equal to 0, then that means the test is inconclusive. So we cannot easily conclude either we have a minimum or maximum, and you have to go back to the first derivative test. So the test to fail lah. This test to boleh fail juga lah. Sebut payah. Next. Okay, so by using the second derivative test, find the relative extremum for fx. Okay, so let us go and find out what is the first derivative and then differentiate again to get the second derivative. So we need to find two things, the first derivative, the second derivative. Okay, so differentiate them once. We are going to get 3x squared minus 6x minus 24. And then do factorize them because we want to find out what is the critical point. Okay, so 3x plus 2x minus 4. Okay, so when f prime of x equal to 0, so you're going to let them equal to 0. So x is equal to negative 2, x equal to 4. So we need to know, you can say this is stationary critical, ada dua kan. So better to call it as a stationary point. So ini stationary lah. I want to find out the stationary point. Okay, so once we have this stationary point, stationary number, what do we do is that we're going to calculate what is the second derivative. So differentiate f prime again, and then we are going to substitute each of these value. So differentiate them again to get the second derivative. So the second derivative, you are going to get 6x minus 6. So substitute x equal to negative 2. So you are going to get negative 18. So since f double prime is less than 0, this is definitely a maximum. And then test for x equal to 4. So substitute x with 4. So we are going to get 18, and 18 is definitely greater than 0. So I do know this is definitely a minimum. Okay. Next. Okay, so I need to get the point. So let us substitute into fx. So x equal to negative 2 inside fx and x equal to 4 inside the fx. Okay, so when x equal to negative 2, my value of y or f of negative 2 is equal to 60. And when I substitute with x equal to 4, f of 4 is equal to negative 48. Which means that negative 2, 60 is a relative maximum, and for negative 48 is a relative minimum. Okay, done. I wait. Okay, so now this is the optimum problem. Okay, so basically there are a few steps before we can solve the optimum problem. Okay, so the first step, to make sure to identify the variable that you want to maximize them or if you want to minimize them. So read the question very carefully. What are the things that you want to be maximum or minimum? Is it the radius? Is it the height? Is it the volume? Is it the area? Or what is that? So do make sure you know what is the variable. The second step will be to express y into a single variable function. So we're going to try that one. And then we're going to try to solve them. To try to solve for f prime of x equal to 0 because we want to know what are the stationary point. And once we have the stationary point, we're going to check using the second derivative test whether do we have a maximum or minimum. Okay, so I repeat again. So the first step, you need to identify first what are the variable that you need to use or you need to know. And then do make sure to take out all the formula. And once you can write them down as y equal to fx or v equal to something, then do make sure to differentiate those functions. So we're going to differentiate those functions, take the first derivative and let them equal to 0. Do make sure to find out what is the stationary point. Once you have the stationary point, differentiate again to get the second derivative and do make sure to substitute the value of your stationary point to check do you have a maximum or minimum point. Okay, so let us go to the example. I think it will be easier to look at the example. Okay, so example number 4. An open top box is to be made by cutting a small congruent square. What does congruent square mean? Congruent square is this is the square. You have the same length on each side. Bahasa Melayu dia segi empat sama kot. A square. Congruent square, the same length. From the corner of a 12 centimeter by 12 centimeter and bend it up the side. So once we cut the corner, we're gonna bend them up. So mula-mula kita potong dulu. So we're gonna cut the corner. This one, we're gonna cut them first. Once we cut them, we're gonna bend them up. So nanti kita guna pembaris, kita tarik lah. Ni atas, ni atas, ni atas. Okay, so now, how large should the square cut from the corner to make the box hold as much as possible? Okay, so now, the first step, we need to identify what are the things that we are using now. How large should the square cut from the corner? It simply means that we want to find out what is the value of x. So x will be the variable. What is the value of x? And then the second info that we know, we want to make sure that the box hold as much as possible. So in order to make sure the box hold as much as possible, it simply means that we are looking at the volume. So kita nak tengok dia muat banyak mana kan. So we're gonna maximize the volume. Okay, so now the second one, we're gonna take out what is the formula for the volume. So length, width, height. So panjang, lebar, tinggi. So the length will be 12 minus with 2x. So it's supposed to be 12 minus 2x because we cut x over here. We cut the x over there. So this one over here will be 12 minus 2x. And then same thing happened over here. This one's supposed to be 12 centimeter, but then you cut the x over here and cut the x over there. So this one will be 12 minus 2x as well. And the height, so the height will be where you cut them. So the height will be x. Okay, so try to expand them. So it will give you Vx equal to 4x cubed minus 48x squared plus with 144x. So that means I can easily write them down in x. Saya dah tulis semua dalam sebutan x. Okay, so that is the second step. The third step, we're gonna differentiate them and find out what are the stationary point. Okay, so we differentiate them. It will give you 12x squared minus 96x plus 144. So now, do make sure to factorize them completely and find out what is the value of x when dv over dx is equal to 0. Okay, so factorize them completely. So we got a 12, x minus 2, x minus 6. So let each of them equal to 0. So that means either x is equal to 2 or x is equal to 6. So we can actually have two stationary points. The first one is x equal to 2. The second one is x equal to 6. So now we should think a little bit. We do get the value of x, but how can we make sure those value of x will give us a maximum volume? Therefore, you need to check from the second derivative. So that is why you need to calculate the second derivative. Okay, so differentiate this function again. So from your dv over dx, differentiate this again to get the second derivative. So the second derivative is 24x minus 96. So now let us substitute with the stationary point, x equal to 2 and x equal to 6. And do check which one gonna give us a maximum volume and which one gonna give us a minimum volume. So when x equal to 2, the second derivative will give us something that is negative. So I do know I will get a maximum over here. When x is equal to 6, the second derivative will give me something that is positive. So greater than 0. I do know this is definitely a minimum value. Actually kalau tak check pun sepatutnya boleh perasan sebab dia panjang dia 12 tau. So kalau kita cut 6, dan nanti tak ada apa-apa lah sebagai tak ada benda nak tarik ni atas. Sebab dah potong 6 bawah, potong 6 atas. So habis lah satu kertas tu. So kalau ikut secara logik lah. Logiknya kalau daripada kertas tu pun kita dah nampak 6 dengan 6 memang confirm yang ini akan jadi minimum. Tapi of course we need to test. Okay, so that means the maximum volume will be when x is equal to 2. So atas potong 2, bawah potong 2 lah. Okay, so now let us go to example 5. Sekejap, lihat sekejap. Tarik nafas. Okay, so example 5. You have been asked to design a 1 liter oil can shaped like a right circular cylinder. Which dimension will use the least material? Okay, so now what do we know so far? Right, so if we have a cylinder, let me change the color, otherwise we cannot see. Okay, so if we have a cylinder, then this one over here, if this is the center, this is R, this is also R. Oops, R. So that means this is 2R and the height will be equal to H, the height H. Okay, so let us think a little bit. Which dimension? What do we mean by which dimension? So if we draw a cylinder, two of the most important thing is to know the radius as well as the height. So there are two things that we need to know. What is the radius and what is the height? So those are the dimension. So kena tahulah radius berapa, height berapa, baru kita boleh ada dimension dia. Okay, so what else do we know? Use the least material. So we want to shape them. Use the least material. So that means we are talking about the area. So kalau dia kata hold as much as possible, that one will be volume. But use the least material, that means we are talking about area. Okay, so for the area of a cylinder, it will be 2 pi r square plus with 2 pi r h. Okay, so why do we have 2 pi r square? So we got a can, right? So we should have two circles. So one on top, one at the bottom. So that is why you have 2 pi r square. 2 pi r h simply belong to this shape yang kat sini. So this is 2 pi r h. This is pi r square. This is also pi r square. Since you need to close them, that is the reason why you are having 2 pi r square. So kalau dia kata open kan, open, cylinder tu kena open, then it mean you only have pi r square. So kalau open maksudnya ada bawah je lah, tak perlulah letak dua. Yang ini of course lah kena tutup, nanti habis lah kita punya minyak tumpah. So 2 pi r square, close them. Okay, so now what do we do next is that they did say something about 1 liter oil. 1 liter oil actually belong to the volume because we need to make sure we fill up the can. So fill up the can, that will mean the volume. So I need to make sure the volume is 1000. 1 liter is 1000. So the formula for the volume is pi r square h. So that means h is equal to 1000 over pi r square. So why did I do this? This is because I want to make sure for A, I want to change everything either in terms of R or everything in terms of H so that we can differentiate them straight away. Sebab nanti kalau dia ada dua variable, then kita akan buat implicit kan. So I don't want to do implicit. That will be quite long. So I want to straight away differentiate them. So that is why I'm finding out some relation between H and R. So I'm either changing H into R or R into H. Okay, so go back and substitute H is 1000 over pi r square. So it will give you A is equal to 2 pi r square plus 2000 r to the power of negative 1. So now I already have A in terms of R. So that means we can differentiate them to get the first derivative and we can find out what is the stationary point and differentiate them again to get the second derivative, and then we're going to test our stationary point inside the second derivative to check do we have a maximum or minimum. Okay, so now differentiate them. It will give you 4 pi r square minus 2000 r to the power of negative 2. Let them equal to 0. So you're going to solve and you are going to get r cube is equal to 2000 over 4 pi, and r is actually the cube root of 500 over pi. So of course now you can actually use your calculator and find out what is this value. So boleh ganti and cari nilai dia berapa lah. I'll wait a little bit because you might need to write them down. Sebab nak tulis kan, so saya ni sikit lah, slow sikit. Okay, so now we already have the value of the R. So what we should do next is that we need to go back and try to substitute and check. Do we have a minimum or maximum? So tadi dah dapat berapa tadi? 5.42. Okay. So the A over the R, we are R is equal to 5.42. Okay, so the A over the R is 4 pi R minus 2000 R to the power of negative 2. So we're going to differentiate them again to get the second derivative. So d2A over the R square is equal to 4 pi minus 2000. So bring the power down. So we're going to get negative 2 R to the power of negative 3. So now substitute with R equal to 5.42. So when R is equal to 5.42, you check, do you have something that is greater than 0 or do you have something that is less than 0? Actually, you should be able to see, right? This is definitely positive because this is a positive number plus with a positive number, definitely positive then. Okay, so now when you substitute the value in, you're going to get 37.69. So this number is actually positive. So it simply means that we are going to have a minimum. So the question asks for the least material is going to be the least. So that means when R is equal to 5.42, substitute back into the H. H tu dia apa? 1000 something kan? Okay, so H is equal to 1000 pi R square. So substitute R equal to 5.42. You are going to get H equal to 10.84. Therefore, R equal to 5.42 and H equal to 10.84, we'll use the least material. So it will definitely give you the least material. Okay, so I think that's it for this lecture. Rasa macam dah habis dah lecture 1. I think I'm done. Yes, I'm done. Okay, never mind. It's already 12:47. Kalau saya start pun nanti macam dah hujung-hujung. So better for me to start it next week. Next week lah, hari Ahad kita start. So I already done optimization. After optimization, what else? Rate of change. 10.2 is the rate of change. So we're gonna solve for rate of change later on. So dah siap ini, kita buat rate of change pula. Okay, so I'll see you guys next week on Sunday. So bye everyone. Have a nice day. Goodbye. Good day. Have a good lunch. Have a nice lunch. Bye.